Okay, exponential logarithmic functions. We get to solve them. We kind of had a prequel yesterday, so we're just going to talk about it. This is just a review of the properties you already know. You know the one-to-one. If the bases are the same, that means the exponents are equal, yes? Mm-hmm. In logarithmic form, if the bases are the same, that means the ofs are equal, which would be the exponents, would they not? Okay, their inverse property just says if I have if a to the log base a of x, the answer is x. Again, are my bases the same? Yes. Log base a of a, are the bases the same? Yes, so the answer is x. So those are just a reminder of the one-to-one and the inverse property because we are going to use them a lot. Okay, we're also going to be writing from exponential to logarithmic just because it's easier. I will show you the method that they do a lot in CalcChat, but I'm going to tell you it's not a method I just go to immediately. Just changing the form is what I usually do because, bless you, it's just what comes to mind first. Riley, are you good? No, yeah. Savannah, are you good? Okay.
I really want my serum. I'm good.
Okay, so on there you have, on your assignment, there's a section that says original equation, rewrite it, solution, property. So what did you use? Okay, I really don't care if you do a table. First of all, I want you to work down. I don't want you to work sideways. I push that and push that and push that. But for this example, I am going to work sideways to show you what they're looking for. But I don't need you to tell me this is the rewrite, this is solution, this is the property. Okay? They don't need to be headed. So I have... Okay, so I have 2 to the x equals 32. There's different ways we can do this, yes? Okay, now we talked yesterday, and I think I want to use the one-to-one property. How about you guys? Okay, so 2 to the x equals 2 to the what? Fifth. So x equals 5. So that is the 1, 2, 1. Yes? Mm-hmm. So natural log of x minus natural log of 3 equals 0. How would I rewrite that?
Would be x divided by 3.
So I have the natural log of x over 3 equals 0. Now I'm going to show you 2 methods. You might not want to write them both down, and you might want to, okay? One of the things I say is when you're stuck and you can't get to the x, rewrite it. This is an exponential. We're going to put it into what? This is in logarithmic. We're going to put it in what? Exponential. So what's my base? E. So I personally would say e to the 0 equals x over 3. And then multiply by 3 on both sides.
1.
And e to the 0 is 1. So x equals 3. Now, what they're actually looking for you to do, actually I shouldn't have wrote that there, is this. This is in logarithmic, yes? And the base is e. They're looking for you to make both sides an exponential function. Okay, I took both of them and made them exponents. Can I do that? Yeah, because I can do anything I want as long as I do it to what? Both sides. So, over here, the inverse property tells me e to the natural log of x over 3 is just what? X over 3. And we know e to the 0 is 1. So x is 3. So those are 2 ways to do that. Because what they want you to write is it's the inverse property. But I would argue that this is also the inverse property because you went from logarithmic to exponential, and aren't they inverses of each other?
Yes.
Yes. Now, I don't care which method that you use. I really don't. I am not personally drawn to this method. It is not the first thing I think of. Wasn't hard, was it? No, but it's not what I think of doing. Okay? So you have to choose which one that you would rather do.
Oh yeah, I keep writing I's instead of L's.
Well, you better stop that.
I thought I got out of it until Riley told me last night. I was like, why are you writing I's?
So I have 1/3 to the x equals 9.
3 to the negative x equals 3 squared.
3 to the negative x equals 3 squared. So x equals
Negative 2.
-2. And what property is that?
1 to 1.
1 to 1, because you use the same bases.
Wait, how do you get the negative 2 again?
Because it would be negative x equals 2.
Because the same base.
Yep, because when the bases are the same. And so x equals -2.
Okay.
Other questions? Again, I want you to be able to identify these properties. They're important. They really are. There's a question on your test where I do the problem and you have to tell me what I did. So are knowing the property names important?
Yes.
Yes.
Is it just going to be inverse and 1 to 1?
Well, you condense, expand. What did I do? Okay. Multiply, divide, factor. You know, what math did I do? What?
Isn't the 1 to 1 property also like property 4 though? Property 3.
No, property 3 and 4 are the same. Those are the inverse properties.
I thought 3 was 1 to 1 and then 4 was inverse.
Yes, yes. I don't remember the numbers. Yes, you're right.
Properties of log are number 3 is inverse and number 4 is 1 to 1.
Yeah, because those are about the same basis. Because 2 and 3 are the same. I was making 3 and 4 the same.
I was going to get beat up.
Okay. Now, so I have e to the x equals 7. So it's an exponential. We want to put it into logarithmic. Okay. So we can log both sides, or we can actually just change everything around. Do you want to log both sides, or do you want to change everything around? Okay, so we're actually going to use natural log. Why? Because it's base E. So it's the natural log of
X.
7. Remember, these two have to switch sides. Equals x. So the solution is natural log of 7, because you don't know that, do you? Now, what they were looking for you to do is take the natural log of both sides. And what's this side equal?
1.
No,
X.
x.
Base.
Okay? You see that? So that's what they were looking for you to do. So the property of this would be inverse. So we rewrote and solutioned all in the same step. Okay, now what?
Good question.
Natural log of x equals -3.
E to the negative 3 equals X.
E to the -3 equals x. Okay, so that was the inverse property we used. Now again, if CalcChat you were looking for this, they would put E and E like that. They'd make them exponents, and the left equals x. Yes? Now, this isn't the answer. What's wrong with that? Can I have a negative exponent?
No.
Nope. So it'd be 1 over E cubed. What do you want to do with this one? Natural log of x. I hate that they don't put parentheses. Equals -1. And the reason, because I type these up, I don't put parentheses there is because you need to get used to the book doesn't put parentheses there. I think it's helpful too, because you know I'm taking the log of this. My brain can see the of. Those are the parentheses. So what would you like to do with the log of x equals -1?
Log of -1 equals x. You mean e of -1?
No. What's the base of log when there's nothing in there? 10. So 10 to the -1 equals x. So we did the inverse again, right? So x equals 1/10. Okay, so there's what the basic ones are. Let's challenge ourselves. Oh, there's another one. Oh, log base 3 of x equals 4. It's no different. 3 to the 4th equals x. So x is 3 times 3 is 9. 9 times 9 is 81. Okay, so these are just strategies. I don't want you to write these word for word. They're in your textbook if you need to. Always use 1-to-1 if you can. Yes? Yeah. You should be using 1-to-1. If not, these two are the same. These two are the same thing. If it's an exponential, put it into what? Logarithmic. If it's logarithmic, put it into exponential. So the first thing you should do is 1-to-1. Yes? And then if it's an exponential, put it into logarithmic. Logarithmic, put it into exponential. Do not write that word for word. When I'm doing the switching forms, that is the inverse property. Did you see the inverse property was used more in those problems that we did? Yes. Okay, the inverse property was used more than the other than the 1-to-1 because the 1-to-1 you're just lucky it happens. Better not be doing that word for word, Riley.
No.
Okay.
Just started writing.
I put those boxes up there because I want you guys to see. I mean, this is how we write things in math because they need to be thorough. But when we're writing them for ourselves, do we need to be that thorough? Sometimes. Savannah's like drawing a picture, writing a sentence. What do you do in science? You like write the definitions, draw a picture, and write a sentence.
You eat cereal.
I'm gonna come join you guys in science.
No.
Riley, you tell me when you're done. I'm gonna
What are you writing up there?
She's writing every
Should
word.
underline? Girl, she
Good?
inverse twice.
She wrote inverse, and won't ever know. Okay, so solve the equation. Now it is just solve the equation. Just solve it. So e to the negative x squared equals e to the negative 3x minus 4.
This one's really hard.
Nope, it's not. It's really easy, actually.
That's why I was being sarcastic.
What do we need to do?
Negative x squared equals 4.
Because that's the what property?
1-to-1.
It's the 1-to-1. Now I have an equation. It is a quadratic equation. So how do I solve all quadratic equations? Set them equal to 0, and we're going to move this over here, yes?
Yes.
Okay, so I have x squared minus 3x minus 4 equals 0. And then what?
What's it called? Factor.
factor.
I didn't, Miss Nick.
So I'm assuming you're going to go with x minus 4 and x plus 1.
Yep.
And so x equals negative 1 and 4. Now remember though, like if we were in logarithmic with exponential, my domain is all real numbers, yes?
Yes.
But with logarithmic, it's not all real numbers. It's all real numbers greater than 0. So if this problem had log of x in it, the original, and these were the solutions I got, would they both work? Why not? I got one negative, yes? So my answer would just be 4. So I just cross out the negative 1. But I just want you to be aware of that, okay? With exponential, it doesn't matter because I can put anything in, yes? But with logarithmic doesn't matter, yes. Okay, so I have 3 times 2 to the x equals 42. Divide by my 3. So 2 to the x equals 114. Yes? Okay, now, I would do 1 to 1 right in here if I could. Why can't I not? Why can't I? 14 is not a power of 2, is it? So I can't use 1 to 1, so I need to use the inverse. So exponential, put it into log. Log base what? 2. How do I know it's 2? There's a 2 of 14 equals x. Now, if I wanted to put that in my calculator, I do the change of base. So it's log of 14 over log of 2. And then you could put it in your calculator and get an approximate answer. Am I good?
Yeah.
Okay. So, natural log of 5 minus the natural log of x equals 0. You've essentially done this problem. Both of them. You do them. You do them.
Equals 5.
Matt, what do I have to do first with C?
5 over x, isn't it?
So I have to condense it.
Yeah.
So I have the natural log of 5 over x. And then what do you do when you say then what?
Did you turn it into an E?
Mm-hmm. When you get to the point and go, then what? That is when you switch forms. So it's e to the
0.
equals
5
5 over x. Now, so it's going to be 1 equals 5 over x. So x equals 5.
It's almost like I said this. This is Nick.
You said it last time. You didn't say it this time.
Yes, I did.
I didn't hear you. Cadence, what are you going to do on D?
5 to the negative x equals 5 to the third.
So x equals...
Negative 3.
So this one we use the inverse on.
And then 1, 1.
And this we use the 1 to 1.
Whoa, what'd you do? Oh, you're fine. Oops. Hey, you're
She's
fine.
processing.
Yeah.
You got it? She processes by speaking, and no one understands but herself. You got it, Jaden?
Yeah.
Okay. Okay, e to the x equals 13.
I just don't know. Don't you able to change it right away?
Yep,
So log.
not log.
Natural log.
Natural log of.
Natural log. 13 equals x.
And are you done?
No, you're never
Yes.
done.
You're done.
Yes, I did it right.
Natural log of x equals -8.
E of -8 equals x.
E to the -8.
Sure.
E of -8 means this.
I'm at
Because of means to multiply, yes?
2.
Am I done?
No.
No.
1 over e to the 8.
1 over e to the 8th. I'm going to tell you right now that over half of you will miss points on your test because you won't get rid of the negative exponent.
I was leaving.
And I will cry. You will have tear stains on your tests.
I mean, I'll probably hand it into you with your stain already on it.
You'll have my tear stains. Okay, e to the x plus 5 equals 6.
D. 60?
60.
You gotta subtract 60.
Subtract the 5.
Or, yeah.
You change this.
So e to the x equals 55.
Mm-hmm. Ellen.
Yeah, Ellen.
So x equals the natural log of.
Done.
Log base 3 of 5x minus 1 equals log base 3 of x plus 7.
5x minus 1 equals x plus 7.
Why?
Because they both have the same log.
And so what rule is that?
1 to 1.
1 to 1. And now I just have a basic algebra problem, right? Minus x plus 1. So 4x equals 8. X equals
2. Wait.
You said it and they're like, wait. I'm like, okay.
I confused myself after a semester.
I'm like, you answered it. I think it's our last one. Oh, no, we just got harder ones. They just get more properties to use, yes?
Yeah.
So I have log base 6 of 3x plus 14 minus log base 6 of 5 equals log base 6 of 2x.
So you keep the first 2 and then you subtract log base 6 of 2x.
Okay, why do you want to subtract? You mean add?
Why did you divide them? Sure.
Okay, so you can do two things. This means to divide, yes?
Yeah.
But if I add it to the other side, I'm what? Multiplying. So when I divide by something and I solve it, I'm going to have to multiply anyway. So do you want to multiply before you?
Yeah.
Okay. So we're going to add log base 6 of 5 over to the other side.
Yeah.
Okay. Now what?
2x equals 5.
No. No. What does the plus mean?
Multiply.
Multiply.
Oh, wait, multiply.
So log base 6 of 2x times 5.
Yeah.
Can I just write 10x?
Yeah. You can do whatever you want.
Here, mult. Okay, so 10x equals log base 6 of 3x plus 14. Now what? Oh, yes. Yes, because if it was log base 2, could I do anything else? No. So I would have 3x plus 14 equals 10x. So 14 equals 7x. So x equals 2. Now, what?
That was just a joke because of last time.
Oh, okay. So right now, what I'm telling you guys is before you can do anything, you have to condense or move, yes?
Yeah.
Now I'm going to show you just condensing these two. Subtraction means to divide, yes?
Yes.
So I would have log base 6 of 3x minus 14 over 5
14.
equals log base 6 of 2x. Oh, it's plus 14, yes. Okay, now we have same bases, yes? So 3x plus 14 over 5 equals 2x. Well, guess what? 10x, because I have to multiply. Subtract 3x. 14 equals 7x. So x equals 2.
So did you move the log of 5 over because it didn't have 3x plus 14? Like it wasn't as big as.
I don't know. She just said it, so we did it.
You move either one.
You can do it either time. Now, I'm going to tell you, when you guys get a problem like this, what does your brain usually do?
Shut off.
It shuts off, leaves the room. Yes? So by making the subtraction a multiplication, did you stop your brain from doing that?
Yes.
Yes. I don't know why your brain stops here, because the first thing you have to do is get rid of that. Yes? And you've done it plenty. So it's not like you don't know what you're supposed to do. It's just your brain just goes, eh. So there are multiple ways to do this, but you cannot do this. What did I do?
You just took all the numbers.
I just took them all and said, I'm going to do 1-to-1. I cannot do 1-to-1 until it is condensed. Got it? Okay. So 2 times 3 to the 2x minus 5 minus 4 equals 11. So like, remember when you learned to solve equations, you did like 1 step and then 2 step and then multi-step. That's basically what we've done all day. So what first? Add the 4. And make sure you make this 2t minus 5 an exponent. Sometimes I'll even put parentheses around it so I don't forget. So that would be 15. Okay. Then what? Then divide by 2. So I have 3 to the 2t minus 5 equals 15 halves. And you're going, Miss Mick, I cannot get same bases. You're a horrible person. Yes?
There's not even like a log or anything.
There's not, but can I put one in?
Yeah.
Yep. Log base what? No, 3. So log base 3 of what?
2t minus 5. 15 over 2.
15 over 2. You're doing the inverse. You got to inverse them. Equals
2t minus 5.
2t minus 5. So what are we solving for? T. Okay, we're not there yet. So what do I have to do next?
Add 5.
Add 5. So I'm going to put it in the front just because I can. So log base 3 of 15 halves equals 2t. And divide by 2. So t is going to equal 5 plus log base 3 of 15 halves, all divided by 2.
That was disgusting. So that's our answer?
That's your answer. Now, I do want to show you something. What if I had this? Is that my answer?
No.
Careful.
Yes.
Can I divide this 10 by 2?
No.
No, because it's have to do the log first, yes? And I can't divide the 6 because this is a what on the top?
Function.
It's a quantity.
Quantity.
And until I can do the quantity, so if I could factor out, like if I had a 2 in front of the log, I could take a 2 out of everything, correct?
Yes.
But without it, I cannot.
So that is the answer.
That is the answer. Don't just start crossing things out. I know, Jaden, you love to do that. I know. You and I think Cadence likes to do that too. Okay, so I have log of 4x. And again, guys, it's log of 2 things. So put what around this 4x? Parentheses. Log of 4x minus log of 12 plus the square root of x equals 2.
log of 12 plus square root of x.
Okay, why do you want to do that, Kins?
Because I don't want to divide.
You don't want to divide, but is the 2 log base 10? No. So could we make it log base 10?
Yeah.
It'd be log base 10 of 10 to the what? 2? So do you want to do that?
No.
Or do you want to condense and change it? Either way, you're going to have to do it at some point. I'm going to tell you right now, you guys are not going to remember to do that.
Yeah.
Okay,
Factor.
so what do I have to do with this negative?
Get rid of it.
How?
Factor it out.
Nope.
You have to turn it into.
I have to condense it, right?
Yes.
So it's log of what?
4x over 12 plus the square root of x. Really? Did you tell me to shut up?
Hey. Okay, so negative means to subtract, yes? Okay, now I'm stuck. Yes?
Yes.
So what's my base? 10 to the what?
First,
2.
0,
2
2. I said that.
equals
4x.
4x over 12 plus the square root of x.
I better start writing smaller because I got more steps. Okay, so now what?
Don't give me a.
This is 100, yes?
Yes.
And when I have a denominator, I need to get rid of it. So I need to multiply it over and I need to distribute it, correct? So I would have 1200 plus 100 square root of x equals 4x. Now what?
Now you have to divide by 4.
Can't.
You have to.
Oh, we could. We could divide everything by 4. You're good. Sorry.
Say.
I was thinking you said subtract. Okay, so what do you got? 300 plus 25 square root of x equals 2x.
Equals x. X.
Oh, yes.
Did it.
Okay, we're not done. Do you guys know we have a quadratic equation there? If I square, because a quadratic equation is this, yes? Yeah? If I square the middle, do I get x squared?
Yep.
If I square x squared, do I get x?
Yep.
Yeah. So we better set this equal to.
0.
So I have x minus 25 square root of x minus 300. So what I'm doing is I'm factoring it the same. So I need the factors of 300 that have a difference of 25. So 300 would be 3 times 2 times 5 times 2 times 5, yes?
Yep.
Because 3 times 100. So I needed the difference of 25.
Three.
What am I
20 minus 15 doesn't work, right?
Nope.
So 60 minus 5 definitely doesn't work. 30 minus 10
Nope.
doesn't work. Yeah, 50 and 6 doesn't work. I think I'm going to have to use the quadratic formula. What do you think?
I think we should just kept x equals 300 plus 25 square root of x.
Well, I think we have to use the quadratic formula. Okay, A, B, and C. It don't get hung up on the square root of x. We need A, B, C.
See, I want to change that x to 1.
A, B, C.
A, B, C. So when I do the quadratic formula on this, it's x equals, yes? Yeah? Because it's, when I do the quadratic formula, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, this isn't going to be x equals, this is going to be the square root of x equals, isn't it? Yes?
Yep.
Okay, so 25 plus or minus the square root of 25 squared, 625, minus 4ac, so plus 1200, all over 2, which is 2. This is 1825, isn't it? So 25 plus or minus the square root, and this is 1825. Well, I know 25 goes into 1825, yes?
Yes.
So we've got 25 times, well, 25 goes into 182, how many times? 7? Because 7 quarters is $1.50, no, 6 is $1.57, is $1.75. Anytime you see 25, you guys don't think quarters?
I don't.
Okay.
That's how I figured out 5 cubed.
Yeah.
5 times 5 is 25.
Okay, so 25 times 7 gives me 175. So that would be 75, so that would be 3. 73 prime. Yes? What's the square root of 25? 5. So I have 5 square root of 73 over 2. Now, did I have to use some number sense that since the quadratic formula is x, this one's going to be the square root of x? Yeah. But did everything else work out exactly the same? Yeah. Anytime you have that difference there, you can factor or use the quadratic formula. In this case, the quadratic formula would be x what? Cubed. Now, this is x squared, so to really get it, I would have to do what to both sides?
Stop.
Square both sides. But are you going to square this side? That'd be like gross. But I could write it, couldn't I? So I could write the answer as x equals the square root of all that squared. So what I'm trying to say to you is just because it looks gross doesn't mean you don't know how to do it. It's that you don't want to do it. You know how.
Valid.
Okay, let's see if I got one more. Nope. That's it. So those are your notes for the next 2 days, because tomorrow we'll come in and take attendance and we have the speaker. So if you have questions tomorrow morning, you need to get in here early.
No speakers tomorrow.
Yes, the speaker is tomorrow at 8:30. What?
Sorry.
Okay.